All right, so now we are going to move into taking the derivatives of implicitly defined functions. So an implicitly defined function would be something like this, where you cannot get y equal. Can't be done, right? Because y is inside here and y is here. Every other time we've had explicit. Y is explicitly given in terms of x's. All right, so we're still going to be able to find y prime even if it's given implicitly. So here's your f of x, your y is equal to your f of x, your y is equal to your f of x, and let's go find f prime. So chain rules happening, right? Taking the derivative with respect to x on both sides, reminding yourself you're taking the derivative with respect to x. So taking the derivative with respect to x of x cubed, I get 3x squared. That's it. So taking the derivative with respect to x of cosine of the function, I take the derivative of the cosine, get negative sine, carry the function along, and then multiply by the derivative of the function. Here I'm doing chain rule, so bring the 3 down, carry the inside along to the squared power. Now take the derivative of the inside and get f prime. So it's f prime of x that I want to solve for. So if I just rewrite this, I here see an f prime here and an f prime here. So this is all multiplied, so those are both f prime terms. And 3x squared is the only non-f prime term. So I've moved this over to the other side by adding it. So now I'm going to factor out f prime. And then I can divide through by this term and put it in the denominator. All right, let's redo that same problem, only instead of f, I'm going to leave it as y. So again, I want you to know and think that you're taking the derivative with respect to x. Taking the derivative with respect to x. So the derivative of x cubed is just 3x squared. To take the derivative with respect to x of cosine of y, that tells you that there's a function inside. So you take the derivative of cosine, you get negative sine, you carry that function along, and then you multiply by the derivative of the function, y prime. Again, we're taking the derivative with respect to x of y, so I do chain rule. Bring the 3 down, carry the inside function along, subtract 1 from the exponent, and then multiply by the derivative of that function. Then I pull the 2 y prime terms to the same side of the equal sign by adding this over, factor out the y prime, and then divide. So it is the same answer, and there's just a lot less to write, a lot more clean. So let's go do one together. Okay, so again, I'm just going to suggest that you reinforce I am taking the derivative with respect to x on both sides. So if I'm taking the derivative of an x term, it's just the derivative, just easy power rule, like this one, 4x cubed. Taking the derivative of y to the 4th, I have 4y cubed times y prime, the derivative of the inside function. So here I'm going to use product rule. So I'm going to have first, and so taking the derivative of y squared is going to give me a 2y to the 1 power, right? I'm not going to write the 1 there because it makes it look like it's a prime, right? 2y to the 1 power times the derivative of the inside, which is y prime, plus y squared times the derivative of 6x, which is 6. All right, so let's identify where the y prime terms are. So this is a y prime term, and all of this is a y prime term. So we just get to pick a side. It doesn't matter, there's no right answer here. So I'm going to pull the x, or I'm going to put this on the other side. So I'll get 4x cubed minus 6y squared equal, and I'll keep this here, so I'll get 12xy y prime, and I'm going to subtract this to the other side. All right, and so then if I factor out the y prime here, 12xy minus 4y cubed, 4x cubed minus 6y squared, and then divide through 12xy minus 4y cubed equal y prime. Okay, so I just want to play devil's advocate here and just say, what if I had chosen the other side? What if I had said, I'm going to keep this guy here and subtract this over, And then I would have this 6y squared minus 4x cubed. I want you to see the difference. So if I factor out a y prime, 6y squared minus 4x cubed. So y prime will equal 6y squared minus 4x cubed, 4y cubed minus 12xy. Okay, are these equivalent? They are. So if I think about it, if I multiply top and bottom by a -1, that would give me a negative 6y squared plus a 4x cubed over a negative 4y cubed plus a 12xy. And that's exactly what I have here. So if you can see that you have a negative difference on the top and the bottom, it's the same answer. So this is a fine answer. And this is a fine answer. They're equivalent and no need to change one to look like the other. All right, let's do this one. So here I have tangent. So you know the derivative of tangent is secant squared, carry the angle along, and then multiply by the derivative of the angle. Then you recognize, you see product rule. So first, d second plus second, and then taking the derivative of 2y squared would be 4y to the 1 power times y prime, plus, then taking the derivative here, I'd get 12x cubed, taking the derivative with respect to x, so there's no, you're never going to write x prime. And then moving to this term, so I'll carry the minus 2, derivative of e to the stuff is e to the stuff times the derivative of stuff. Yeah, something I forgot to say. So you're never going to say x prime, right? If you're taking the derivative with respect to x, you get 1, right? If you're taking the derivative with respect to x of y, that's when you get y prime. All right, so let's go and identify where my y prime terms are. They're big, right? So I see 2 of them over here and just 1 over here. So let's move these 2 terms to the other side of the equal sign, right? So negative 2y squared e to the x minus 12x cubed equal. So I'll have 4 e to the x y prime minus 2 e to the y prime. And I'm going to subtract this. So then I'm going to factor out the y prime. And then I'm going to divide. Leave lots of room for these problems, right? And that's it. Let's finish off with one more. So let's take the derivative here. So derivative of e to the 3y would be e to the 3y times 3y prime. And then moving on to here, there's a product. So first, d second, hyperbolic secant x squared, hyperbolic tangents x squared times 2x. So that's first d second plus second d first, and then minus 5y prime. So the derivative with respect to x of 5y is 5y prime. And the derivative with respect to x of e to the 3y is e to the 3y times 3y prime. All right, so identifying your y prime terms, these 2. So let's add this to the other side. So 3 e to the 3y, y prime, plus 5y prime. And multiplying this, I'll get negative 2x to the 5th. Plus 4x cubed. Okay, so same drill, factor out the y prime. and then divide through. Lots of writing. Oops, tangents of x squared plus 4x cubed all over e 3e to the 3y plus 5.